upon 2 into r upon n is x, which is pi upon 2 into x. Okay, now it can be converted or taking limits here. Now let me consider this or substitution. Let me substitute something. What we have to substitute? First let me write here the same thing which is obtained. It is log p we are calculating. Log p is equal to 0 to 1. It is log of tangent of pi x upon 2 into ds. Okay, putting here pi into x, let or putting pi x upon 2 equal to t. If I take t, then x equal to 2 upon pi into t. This is there. For the limits here at 1 t equal to pi by 2. Okay, that is the limit. But dx is equal to what? Is equal to 2 upon pi into dt. Differentiating it with respect to t. With respect to t. We get this dx upon dt equal to 2 upon pi, or dx equal to dt, 2 upon pi into dt. Let me write clearly. Differentiating it with respect to t, we get dx upon dt equal to 2 upon pi, or dx equal to 2 upon pi into dt. This is the value. Now, limits. What are the limits here? Let me change the limits also. Limits when x equal to or at x equal to 1, t equal to pi by 2, t equal to pi by 2, and at x equal to 0, t equal to 0. The limits are here 0 to pi by 2. Try to understand. It is log tan t dt. It is dt 2 upon pi. Let me write here 2 upon pi into dt. Now it can be converted 2 upon pi 0 to pi by 2. What is this? It is nothing but log of, it is sin t upon cos t. Sin t upon cos t tan t. We can write it as 2 upon pi 0 to pi by 2. It is nothing but log of sin t dt minus sin it is 2 upon pi into limits 0 to pi by 2 to pi by 2 into log of sin t cos t. It is cos t in the denominator. It is dt. What is log m upon n? Log m minus log n. That I have separated in two parts. It is first 2 by pi, 2 upon pi, 0 to pi by 2 log sin t dt. Okay. Then minus sin log cos t dt. 2 upon pi, 2 upon pi, 0 to pi by 2 log cos t dt. Now what is the value of log sin t dt? This below. This is nothing but minus pi upon 2 log 2. The value is. It is 2 upon pi. The value of 0 to pi by 2 log sin t dt is nothing but minus pi upon 2 into log 2. This is the value we have calculated, or we can separate. We can calculate this value separately by assuming this as log sin t, and we will substitute as 2 upon pi into the value. It is minus pi by 2 log 2. I think it is minus pi by 2 or minus 1.2. Let me separately solve it. Okay, but these two we cancel out because it is 2 upon pi into the same value minus pi upon 2 log 2. But the same value. This is minus sign, this is plus sign. These two we cancel out. There will minus plus here, plus sign. But first let me check whether log sin t, this we have calculated in the previous lectures or previous one of my lectures. This what is log sin t when 0 to pi by 2 at definite integral. When we start the definite integral, let me find it separately. So it will be then p equal to, this is log p equal to 0 or e raised power 0 is 1. So p equal to e raised power 0, that means 1. E raised power 0 is 1. P is equal to 1 answer. Now let me first find out what is 0 to pi by 2. That I is equal to 0 to pi by 2 log sin t or sin x t or sin x t, no problem. These values are same because cos t will also be the same thing. Answer of log cos t dt 0 to pi by 2 limits and 0 to pi by 2 log sin t dt, they have the same values. This we have done in the previous one of my lectures. Now let me revise here. So this is log sin t dt, this is the first equation. Let me take it. So what is the second point? And it can be converted as 0 to pi by 2 log sin t pi by 2 minus t into dt. What is this? This is by property fourth, I think. By definite property, by property fourth. Okay, x minus, or this is whatever limit is there, a minus x, okay, equal fx equal to log a minus x, or sorry, fx equal to f a minus x or upper limit minus x. This value will be cos t now, for sin pi by 2 minus t cos t. It is 0 to pi by 2. It is nothing but log cos t dt. Now adding this is second equation. What do we get here? If I this I'll do finally I'll dispute this how this value is there. If I add this first and second I here, in the left hand side it will be twice, adding first and second. Adding first, I'm just revising this result. Why this value is equal to that. Twice I in the left hand side equal to. These two are added up. Log sin t cos t. They are in multiplication. We can they are in addition. 0 to pi by 2. It is log sin t dt plus 0 to pi by 2 log cos t dt. Second equation. And this is log n minus log n. So log n plus log n. They will be multiplied with 0 to pi by 2 in the thing of log sin t into cos t into dt. Now if I multiply this by 2 and divide by 2, it will change to it will be log sin 2t. Let me write it here. Finally, what do we get here? The 0 to pi by 2. First is log sin 2t dt 2t. 2 sin t cos t is sin 2t. Log sin 2t in the numerator minus sin 0 to pi by 2. It is nothing but 2, so log 2 here. This is log 2 into dt. It is minus pi by 2 into log 2, which I was talking about. And this value will be same. Let me first solve it. So it is nothing but t into integration log 2 is constant and t is integration of dt. Okay, now putting the limit 0 to pi by 2, it will give us minus pi by 2 log 2. This I was talking the value of that log sin t like this. But what about this? If I take 2t equal to x, let me take the variable. Any variable can be substituted here. Then pi by 2 dt will be pi here. It can be written as 0 to pi here. This is twice I here. Twice I into this. Okay, so let me put twice t equal to u, let me take 2 dt equal to du. Okay, so twice t. Now limits are pi 0 to pi, because at 0 it is 0, u equal to 0, and at this Okay, and at pi by 2, it will be pi only. The limits will be 0 to pi and 2 into dt, or dt equal to du upon 2. It is 1.2, 1.2 here. For dt equal to du upon 2. Try to understand. This is 0 to pi sin t sin u du upon 2 are taken outside. For this 0 to pi limits, it can be converted as 2 into 2 upon 2 here, 0 to pi by 2. Okay, sine any other, let me take this as sine dxd or dt, initially it was dt, can be taken as dt here, it is t dt, we change. Why? Because this upper limit is halved and multiplied by 2, and the upper limit will be halved. This is one of the properties here. This property we have applied, and this was with minus sign. This value we are repeating, minus pi by 2 log 2b. This 2 can be log 0 to pi by 2 sin t dt. The same thing which we obtained, which is I here. It is nothing but I. Twice I is equal to I minus pi by 2 log 2. I taken to left hand side will be I only. Therefore, I means that value. Therefore, twice I minus I equal to minus pi by 2 log 2. This give us substituting. This I here is minus pi by 2 we have obtained log 2. What is I? I was 0 to pi by 2. 0 to pi by 2 sin t. Or sin x dx or sin t dt, no problem. Equal to minus pi by 2. Variable can be any, limits must be same. Limits must not be changed, but variable can be changed. Value will be same. So this is our 0 to pi by 2 sin t dt, and cos, if I substitute here cos t dt, that also will be equal to this. These values were obtained the same thing. Therefore, what do we get here? So log p is equal to 0. What do we get? Log p is equal to 0. Or p is equal to e raised to power 0. That means 1. Answer is p is equal to 1. P is equal to 1. Answer is 1. Question number 6th one we have done. If question 6 is done now, as its value is equal to 1. Question number 6th. Now let me talk about what was 7th question. Now question number 7 is what? Question number 7 here. It says evaluate limit n tends to infinity. N tends to infinity. What is that? This is sine, okay, pi upon 2n into sine 2 pi upon twice n into sine 3 pi upon twice n, and so on, sine n pi upon twice n whole power 1 upon n. 1 upon n. This is 1 upon n. Okay. Now let me take it as p. So solution here. We are finding out solution here. In solution, we consider first this product as p. So let p is equal to this whole product is equal to p limit n tends to infinity. Within bracket it is sine pi upon twice n, sine 2 pi upon twice n, sine 3 pi upon twice n, and so on. This is sine n pi upon twice n whole power 1 upon n. This we cannot forget. 1 upon n power complete. Just mistake there in the previous question. We didn't take this 1 upon n, but finally we take that. Okay, took that there. Now question: taking log on both sides. Taking log on both sides. On both sides. So what do we get here? Now logarithm we are taking here. Log p in the left hand side. Log p is equal to limit n tends to infinity. It is log of sine. Sorry, 1 upon n again I forgot. So this is 1 upon n here within bracket log of sine pi upon twice n plus log of sine twice pi upon twice n plus log of sine thrice pi upon twice n plus and so on plus log of sine n pi upon twice n within bracket this. Okay, now this is limit n tends to infinity 1 upon n. Now to find the rth term of the series. Rth term of the series will be r is equal to 1 to n. This is log of sine. What do we see here? This is pi to pi 3 pi. It means r pi upon twice n. Okay, this is rth term here 1 upon n rth term. Now it can be converted into definite integral. Now r upon n is x, or let me further write it down as limit n tends to infinity. This is sigma sine r is equal to 2n log of sine is pi by 2 into r upon n into 1 upon n. In the last I put here 1 upon n so that it can be considered dx. It can be converted into definite integral at 0 to 1 limits. Okay. This is log sine of pi by 2 into x, right once into dx. Okay, so this is log this value. Now let me write about this is okay, dx. Now substituting pi by 2 x equal to pi by 2 into x equal to t. Let me consider. So log p, what we are calculating, log p is equal to 0 to 1. It is nothing but log of sine pi by 2 into x into dx. Putting here pi by 2 x equal to t definitely. Okay, therefore pi by 2 into dx, differentiating it with respect to t, we get here, pi by 2 into dx equal to dt, or dx equal to 2 upon pi into dt. That will be substituted. Okay, now what about limits? Changing the limits here at x equal to 1, t equal to pi by 2, t equal to pi by 2. Okay, and at x equal to 0, t equal to 0. The lower limit is 0, but the upper limit has been changed. T equal to pi by 2. The limits are 0 to pi by 2. It will be 0 to pi by 2, but 2 upon pi in the end, which was in dt, dx equal to 2 upon pi dt. So 2 upon pi I have taken out of the sign of integration. It is log 0 to pi by 2 limits. It is log sine t dt. Now, to this we know what we have just calculated with the answer of this question. So let me write that very direct minus pi by 2 log. The answer of this is 2 upon pi into minus pi by 2 into log 2. This we have just calculated. We know since sign of integration 0 to pi by 2, log of sine x dx equal to minus pi by 2 log of 2. This is the answer we just calculated. This value there, so pi cancel out, it is minus log 2. It can be written as log of 2 raised to power minus 1, which is nothing but log of 1 upon 2. Log of 1 upon 2 log p is equal to log 1 upon 2. Therefore, p is equal to 1 upon 2. Log cancelled out. P is equal to 1 upon 2 answer. Answer is 1 upon 2. This is the question number 7 we have done. Okay, let me take question number 8. Now, let me take question number 8. Question number 8 is of what kind? Let me check it. Okay, so question number 8. Okay, question number 8 is, it says apply the definition of a definite integral as the limit of a sum. Okay, this is the limit of a sum. So question number 8 is limit n tends to infinity with within bracket factorial n divided by n raised over n whole power 1 upon n can be written as limit n tends to infinity. It is 1 into 2 into 3 into 4 and so on up to n. Factorial n means n raised over n whole power 1 from n can be written as limit n tends to infinity is nothing but 1 upon n, 2 upon n, 3 upon n, 4 upon n, and so on. It is n upon n another whole power 1 upon n. How can we taking log? Taking log on both sides. So first let me consider this as p. Let p is equal to this whole. Limit n tends to infinity. So 1 upon n, 2 upon n, 3 upon n, 4 upon n. Why? Because n upon n is n times. N times. This is n upon n in the n. Whole power 1 upon n. Therefore log of p is equal to, now taking log on both sides, we get log p is equal to limit n tends to infinity. 1 upon n will come before. It is 1 upon n log of 1 upon n first plus log of 2 upon n plus log of 3 upon n plus and so on. Let me write log n upon n. This is what we have obtained. Now writing the nth term of the series, sorry, rth term of the series. Rth term of the series b. This is equal to limit n tends to infinity 1 upon n sigma sine r is equal to 1 to n. This is nothing but log of r upon n here. Why? Because 1, 2, 3 and so on, log r upon n. Okay, this is rth term. Now let me write it here. So finally we obtained the solution we are finding out. Solution we are finding out of this question. Log p that we have obtained, log p is equal to limit n tends to infinity. Let me write first sigma sine r is equal to 1 to 1. It is log of r upon n into 1 upon n. No problem. So let me take this as definite integral. What's the definite integral of this series? It will be nothing but sine of integration 0 to 1 is log of x here into dx. Log of x into dx. Okay. Log of x into dx. Now integrating this by parts. Integrating it by parts we get. Now integrating it by parts. Considering log x as first function. Considering of taking log x as first function and unity as second and unity as second. So we get, what do we get here? Log p is equal to, we are calculating log p on the left hand side. On the right hand side we are integrating it by parts. Log x as it is integration of 1, because unity has taken as second function, is x here. Integration of 1 is x minus sign. Now different, this is limits 0 to 1 going forward. 0 to 1 limits here. Now differentiation of log x is 1.x into x integration of 1 into b. It is nothing but log 1 in case in both cases is 0. Why it is 0? Because log 1 is 0, log 1 into 1, log 1 0, log at 0, 0 into something 0, it is 0 in both the cases. In second case, x is cancelled out, 1 into bs means x with integration 0 to 1 minus 1 is the value here. It is minus 1. Log minus 1 in between, it is minus 1. It can be written as minus 1 into. What do we get here? It is nothing but minus log e. Okay, it can be written as minus log e. It can be written as minus log e. Log e is 1, or it is log 1 upon e is equal to log minus sign is there. Log e raised to power minus 1. It is log 1 upon e. What do we get? Log p is equal to log of e raised to power minus 1. That means log of 1 upon e. That means p is equal to 1 upon e. Therefore, p is equal to 1 upon e also. Finally, question number 8 is 1 upon e. P is equal to 1 upon e also. Let me take 9th question now. What is question number 9 say? Question number 9 is for the limit. What is that? It is limit. Okay. It is limit n tends to infinity in bracket. It is 1 plus 2 raised to power 10 plus 3 raised to power 10 plus and so on. N raised to power 10. Okay. Divided by n raised to power 11. It is 11 here. N raised to power 11. Now if I take, let me take the limit n tends to infinity, it can be further, n tends to infinity. Okay. And this is 1 upon n. If I take common out of this n raised to power 11, it will be 1 plus 2 raised to power 10 plus 3 raised to power 10 plus 2n raised to power 10 divided by n 10. This is nothing but this value. So what do we get? This is the limit n tends to infinity. We are solving it. 1 upon n. Here it is 1 upon n raised to power 10, the first one. Plus 2 raised to power 10 upon n raised to power 10. Plus 3 raised to power 10 upon n raised to power 10. Plus and so on, n raised to power 10 upon n raised to power 10. This is the value here. Now this is sum of the series. Okay, and here no need of taking log here. What is rth term of the series? Rth term of the series will limit n tends to infinity. This is 1 upon n. Sigma sign r is equal to 1 to n. Let me take. It is nothing but r raised to power 10 upon n raised to power 10. Alright. This is nothing but x raised to power 10. So if I convert this to definite integral, or let me write it further. This is limit n tends to infinity. It is 1 upon n. Sigma sign r is equal to 1 to 1. This is r upon n whole power 10. Now converting this into definite integral, 0 to 1 limits. 1 upon n is there, 1 upon n is here. It is x raised to power 10 into this. Try to understand. Integration will be x 11 upon 11. Because x 10 integration. This is x here, x raised to power 10 upon n is dx. Now we can put the limits here. 0 to 1, this is nothing but 1 upon 11. So value of this whole series is equal to, we are not to consider this as P here because this is not a product. This is sum of a series, summation of series given in this case. The answer is 1.11 of this question because this is just x raised to power 10 integration of that and then the limits. So 1.11 is the answer here. So question number 9 we have done. Let me talk about the next question, which is the 10th one. Now question number 10, what does it say? Question number 10, let me talk about now. So question number 10 is limit 10 tends to infinity. The limit n tends to infinity of sigma sign here r term is 0 to n minus 1, no problem. It is n upon n square plus r square. It is given to us. The limit of consequence that this is equal to limit n tends to infinity sigma sign r equal to 0 to n minus 1. Now if I take n square common in the denominator, you will get 1 plus r upon n whole square. Okay, now 1n cancelled out. It is nothing but limit n tends to infinity. This is r term given to us. R is equal to 0 to n minus 1. It is 1 upon n, 1 upon 1 plus r upon n whole square. Okay, now this is summation of series. Now we can convert this into definite integral at limits are 0 to 1, which we have already done. At r equal to 1, 1 upon n is 0 because n tends to infinity, n tends to infinity here. And at r equal to n, it will be n upon n 1, 0 to 1 limits. It is 1 upon n is dx, it is nothing but 1 upon 1 plus x square into dx. 1 plus x square here. R upon n is x. Now this is nothing but tan inverse x. Limits 0 to 1. So tan inverse 1 minus tan inverse 0. Tan inverse 0 is 0, but tan inverse 1 is 5 by 4. Minus 0, the answer is 5 upon 4. 5 by 4 is the answer, 5 upon 4. For tan inverse 1, tan 45 degree is 1. Tan inverse 1 equal to 5 by 4. Answer is 5 by 4. Question number 10 is 5 by 4 answer. So let's write here. Answer of this is 5 upon 4.